Greetings and welcome to Dynamics videos. Today we're going to go over the overview of dynamics. In other words, where does dynamics fit in the greater picture of science and engineering learning? And what are the components of dynamics? Dynamics fits into engineering learning in a way that we call a thing called mechanics. So let's start with this. In both physics and in engineering, there's an overall category called mechanics. Now, mechanics has three different areas. One is called statics, and that is the analysis of non-moving objects. One is called dynamics, and that is the analysis of moving objects. And a third is called fluid mechanics. And fluid mechanics is just the statics and dynamics of fluids, like gases and liquids. Well, this course is dynamics, so let's take dynamics and break it up into its parts. There are two parts to dynamics. One is called kinematics, and the other is called kinetics. Now, kinematics has to do with the motion of objects irrespective of their mass and the forces applied to them. Now, you've had physics and you've learned kinematics in physics before. So the things that are discussed in kinematics are the position of an object, its velocity, and its acceleration, and how all of those are related with respect to time. So notice, in position, velocity, acceleration, and time, there's nothing to do with force and nothing to do with mass. There are kinematic equations, and maybe you remember them. Here's one of them. The final position of an object is equal to its initial position plus its initial velocity times time plus 1/2 its acceleration times time squared. Notice this is an equation. It's a fundamental principle that relates position, velocity, acceleration, and time. And there are other kinematic equations as well, and we'll get into them as the course goes on. Kinetics, we tend to break up into three different categories. And really, these are three different ways in which we are now able to incorporate mass and force into the motion of an object. And again, these three methods of kinetics are something that we've learned before in physics. The first is Newton's second law, relating force, mass, and acceleration. The second is conservation of energy. And what we do with conservation of energy is we bring in potential energy, kinetic energy, and work. So three energy terms that allow us to analyze the motion of objects. And the third is impulse and momentum, and the relationship between impulse and momentum. So dynamics is really what I call going around the helix, where we learn something and then we learn it at a certain lower level, and we go around the helix and we learn it again at a higher level and again at a higher level. And as we go through dynamics, we're taking things that we learned in physics, that being kinematics, Newton's second law, conservation of energy, and impulse momentum, and going around the helix and learning them more deeply, learning them at a higher level. In this, give me just a second here. In this course, we actually go through and do all of kinematics and kinetics once, and then we do it again. And the first time we go through and do it, we treat every object as, the first time through, a particle. In other words, if we were talking about a car, we would take that whole car, compress it into one point, one particle, acting at the centroid of that car, and we would apply all of these principles to that particle. The second time we go through, we apply all of these principles to an object, where an object is made up of, let's try this, me drawing a car, the entire object. And when you have an entire object, not everything on the object is traveling at the same speed, acceleration, etc. For example, the tires are traveling at different speeds around the tire than the centroid is moving. And you could have something in the back of this car that was moving one direction or another. When we go around the second time, we start to look at all of the different particles and their relative velocities and energies and impulses, etc. If you look at the way the book is laid out, the first few chapters go through and apply kinematics and kinetics to a particle, and then the second few chapters go and do that same thing for an object. All right, real quickly, I've got Khan Academy is a great resource for the physics that we've learned in the past. And I've got a screenshot here from the Khan Academy physics section. Oops. And we'll see that physics is made up of a bunch of different things, but I'm going to just grab these few here. Actually, put that one in as well. And these are topics in physics. Well, this is kinematics in one dimension. This is kinematics in two dimension. This is the first kind of kinetics, Newton's second law. This is the second kind of kinetics, work and energy. And the third kind of kinetics, impacts and linear momentum, so impulse momentum. And then centripetal force and acceleration, torque and angular momentum, and oscillation and waves are other applications of these first five. And so back in physics, when covering these 8 topics, we were going around the helix of learning this material the first time, and now in dynamics, we'll go around the second time, and we will do all of those 5 basic building blocks and then extend that knowledge into centripetal force and gravitation, torque and angular momentum.